Hi, depending on where you are, good morning, good afternoon, and good evening. Welcome to this service briefing webinar on AWS RoboMaker simulation. I am Pulkit Kapoor and I do business development for AWS Robotics. We have a packed agenda for you today. We will start with a brief overview of the mobile robotics market and the challenges developers face to build intelligent robotic solutions. We're going to learn about the RoboMaker simulation offerings, including key use cases and customer examples. Next will be the fun part, where we will have a service demonstration in the AWS console. I will leave you with some resources to dive deeper into some of the features we discussed today. In the end, we will also have some time for Q&A. I want to start by talking about Robotics Industry segment today. Industrial robotics has been around for several years. Fixed robotic arms have been used on the assembly lines in manufacturing facilities since the mid-1900s. A big change occurred about 20 years ago when robotics technology enabled automated indoor vacuum cleaning devices. And the last 10 years have seen strong growth in commercial robotics. For example, use of collaborative and autonomous robots in warehouses. All trends point to strong growth in autonomous mobility in the next few years. By 2023, mobile autonomous robots will emerge as the standard for logistics and fulfillment processes. And it's not just fulfillment. By 2030, we expect 70% of all mobile material handling equipment will be autonomous. These autonomous robots are being used in many industries today, from logistics to construction, and in retail and consumer homes. But building such robots with a high degree of autonomy and intelligence is difficult and time-consuming. Robotics is a multi-domain field that requires iterative development and skills in specialized domains such as mechanical, electrical, and artificial intelligence. Due to the complexity of platforms, before a developer can start writing application code, they often have to spend hours or days to ensure the development environment is set up properly. A cloud service can offer a pre-configured development environment to solve this pain. Most roboticists spend long periods of time prototyping as they evaluate all the different components, such as sensors and actuators, necessary for autonomous operation, while they optimize for both functionality and cost. A cloud service could help accelerate the prototyping in a simulated environment. Additionally, not all developers working on robotics applications have access to robot hardware, as one, this can be extremely costly, and two, typically what is being used in prototyping is never the same as what goes to commercial production. A simulation environment is a huge help in such cases. Here are the three core benefits we have heard from customers for using simulation in robotics development. First is the ability to reproduce and test the exact scenario that have triggered unexpected behaviors in the past, including edge cases and unsafe conditions. This is difficult when testing with physical robots. Second, you can expand test coverage by programmatically testing many scenarios using parameterized and repeatable simulation. Third, you can speed up the clock and run simulations faster than real time, producing results in a fraction of the time it would take on physical robots. And this matters for your business because it means faster time to market for your next robotics project, increased feature release velocity for your teams, and less time spent debugging expensive defects in the field. So what are the common use cases of simulation in robotics? Customers are using simulation for testing robots more robustly for a variety of testing scenarios and edge cases, such as this PR2 robot in a virtual hospital world. Simulations are being used to create synthetic data sets more cost effectively and covering a multitude of variations, such as these different types of furniture models. Lastly, you can also use simulations to train machine learning models more rapidly by presenting the robot with a multitude of environmental scenarios, such as training the AWS Deep Racer robot, which is learning to race on different racetracks in simulation. You may ask, why do I need to run these simulations in the cloud? You get the most value out of simulations when you run a lot of them. You get much more robust learning when you run a lot of simulations because you test a lot of scenarios. Your cost per image for synthetic data generation workflows is much lower when you run a lot of simulations with large amounts of variations. Additionally, for machine learning workflows, you have much faster iteration and training speed when you train many simulations concurrently. In the end, running simulations in the cloud is all about scale and improving the quality of your software. So at this point, we have determined that using simulations in your development workflow can provide multiple benefits, from increased feature release velocity to a faster pace of innovation. However, there's some key challenges and blockers developers face when getting started with simulations. Creating 3D model assets to build a virtual representation of your robot along with any objects and 3D worlds is difficult. Infrastructure required to run simulations is hard to configure and standardize across the team, and doesn't scale when you need to run compute-intensive simulations or run many simulations concurrently. This is particularly challenging when your simulations must communicate with external applications and control systems or have complex networking configurations. Finally, it is hard to get consistency across developers' local simulation environments and create an easy way to automate simulation workflows. AWS RoboMaker was designed to help solve these challenges. The AWS RoboMaker service was introduced in December 2018 at re:Invent. The service brings cloud scale to robotics, especially helping robotics companies simulate applications concurrently in the cloud, as well as deploy applications to robots from the cloud. Today, we will be focusing on RoboMaker's simulation offering. AWS RoboMaker enables you to easily create simulation worlds and run simulation jobs without provisioning or managing any infrastructure. By removing the undifferentiated heavy lifting, your teams can focus on your domain-specific value-add tasks, such as algorithm design and testing. There are multiple benefits to running simulations in the cloud with AWS RoboMaker. First is the access to cloud scale. The service automatically scales the amount of compute required to run the simulation, up to 15 virtual CPUs. In addition, you can horizontally scale by running hundreds of simulations with a single API call. RoboMaker provides enterprise-grade availability with built-in health checks to ensure simulations run smoothly and reliably. The service is fully managed, meaning that you don't have to worry about provisioning and running the Gazebo software stack and only need to focus on preparing your ROS application. RoboMaker is integrated with multiple AWS services, enabling you to easily extend cloud functionality like CloudWatch logs, machine learning services, data storage, and analytics services, and move more to your simulations. Finally, with pay-as-you-go pricing, you only pay by the minute for the resources you consume. One simulation unit or one virtual CPU and 2 gigabits of memory costs 67 cents per minute. Next, let's look under the hood into this managed robotics simulation offering. Let's start with learning about robotic simulators. 3D simulators are popular tools for robot application developers. Here are some of the key components. First are 3D models or mathematical representation of an object's physical body in three-dimensional space. Next, 3D simulators commonly include a physics engine, which simulates realistic movements by calculating physical systems like rigid body dynamics for collisions. 3D rendering engines are used to build and render graphics in the environment. Finally, 3D simulators for robotics support a variety of middleware software that can be used to accelerate the development of robot applications. There are many 3D simulators available to robotics developers. However, today we will discuss Gazebo, a commonly used simulator supported by Open Source Robotics Foundation, OSRF. Gazebo supports multiple 3D model types and physics engines, a 3D rendering engine called Ogre, and interfaces with a few different middleware software, including the Robot Operating System ROS, which I will reference throughout this presentation. AWS RoboMaker supports Gazebo 7 and Gazebo 9 today, the Open Dynamics Engine, Ogre, and ROS applications. Next, let's look at what are the key ingredients to getting started with simulations. There are four main steps to running robotic simulations. First, you have to decide on the fidelity of the simulation that is appropriate for your application. Next, you will have to start with a model of the robot and the environment, which we call the simulation world. These models of the robot and environment we feed as inputs into a simulator that is running on some compute infrastructure, such as the highly scalable and reliable RoboMaker simulation infrastructure. Lastly, you need to write test cases to verify that the robot behavior is safe and works as designed in the simulation world. Let's start with the testing scenarios and fidelity. There are a wide range of test scenarios that are well suited for simulation. Low fidelity simulation can be leveraged when testing the communication pipeline, external fleet management software, or running software load tests. When the scenario requires a physics engine to test real-world conditions, 3D simulators like Gazebo are a good option. Today, running Gazebo-based simulations in RoboMaker is particularly well suited for medium fidelity simulations to test things like localization, planning, and behavior algorithms. Finally, high fidelity simulations are required when you test scenarios include things like vibrational behavior, slippage, and motor saturation, and high accuracy perceptions. Robot application development and testing will likely include multiple simulation tools for different types of scenarios and simulation worlds. The simulation world must match with the needs of your application. Next, let's take a look at the simulation environment. These are some of the examples of open source simulation worlds. On the left is a virtual Mars environment from NASA JPL, with the model of the Mars rover trained to navigate the uneven Martian terrain. On the right is the AWS open source hospital world with a PR2 robot and common hospital assets to help developers test their applications before deploying robots in healthcare settings. You can also simulate industrial settings such as in this AWS open source warehouse simulation world. Here you can see two robot arms transfer an object to a mobile robot. The robot autonomously navigates to a picking station with the two robot arms. You can see the view from the mobile robot's camera sensors as well as the map the robot has created of its environment. Here you can also see the visualization of the robot arm, and you can plan its path before executing it in simulation. But creating such realistic simulation worlds for your application can be both time-consuming and expensive. Moreover, for many AI applications, you require training the robot in hundreds of simulation worlds with different layouts and furniture variations. AWS RoboMaker WorldForge solves this challenge. It is a new RoboMaker capability that automatically generates one or more indoor simulation worlds within minutes. WorldForge provides out-of-the-box templates for room layout and floor plans that you can use to generate a simulation world in minutes. And it's cost-effective as it only costs $1.50 to generate a world versus thousands of dollars to create one from scratch. You can use the RoboMaker console or command line interface to generate hundreds of worlds with different layouts and furniture types. And what's best is that WorldForge worlds easily integrate with RoboMaker simulation for testing or training workflows. Here is an example of 10 simulation worlds generated with different layouts and furniture variations from a one-bedroom WorldForge template in minutes and at fraction of the cost. Next, let's look at some common RoboMaker simulation use cases and customer examples. We have customers across the robotics industry segment using RoboMaker simulation and getting great value out of running simulations in the cloud. Let's look at some of the common use cases customers are finding value with RoboMaker. Customers use RoboMaker simulation for two main use cases: regression testing and multi-robot simulation. Let's take a deeper look at these use cases with some customer examples. One of the key software validation best practices is regression testing with a continuous integration and continuous delivery or CI/CD pipeline. AWS RoboMaker makes it easy to test your robot application under many scenarios by running tens or hundreds of in-parallel parameterized simulations with a single API call. These tests can be triggered with every code commit in your CI pipeline or with nightly builds to reduce the number of software defects and ensure that your new code does not have any unintended consequences on robot behavior. With over 5 million units actively deployed, iRobot uses AWS RoboMaker in their continuous integration pipeline to easily scale and run hundreds of tests in simulation for each software release candidate. iRobot is able to reduce costly and time-consuming physical testing and provide test scenarios at the developer's fingertips. This video shows a Roomba running in a virtual AWS small home simulation world and using the synthetic sensor data to systematically navigate around obstacles, such as this wall. It's able to detect the wall and the couch and change its path to clean around these obstacles. Developers can write additional tests to check the docking behavior or use the simulation data to clean and navigate more intelligently. We've also heard from a number of customers about how difficult it is to test orchestration and navigation of a fleet of robots. As an example, when you have multiple models of robots operating in the same environment, relying on physical robot testing requires a significant logistics work before you can even begin to test. AWS RoboMaker enables you to simulate an entire fleet of robots by running multiple Gazebo instances in parallel and managing the interaction between them using Gazebo plugins. Bastion Solutions is a great example of a customer who has used this capability and simulated more than 35 robots in their AWS RoboMaker environments. Here's an example of a simulation of two robots in the AWS warehouse simulation environment. The robots use the synthetic LiDAR information to plan a path such that they avoid colliding into each other. We have learned about the value of simulations and some common RoboMaker simulation use cases for regression testing and multi-robot fleet simulations. Now let's jump into the console and see RoboMaker simulation features in action. This is how the RoboMaker console looks like. On the left-hand side, you will find various sections for common robotics development tasks, such as code development, world generation, simulation, and fleet management. In today's demo, we will do three things. We will generate a new WorldForge world using a template. We'll then use a sample ROS application and build it in RoboMaker's Cloud9 development environment. And then we'll use the robot and simulation application bundles to launch a gazebo simulation using the WorldForge world and visualize the robot's sensor data in RViz. So let's start with WorldForge. So WorldForge, as I mentioned, is the new capability for generating simulation worlds in RoboMaker. You can start with a template in WorldForge. WorldForge comes with 4 different sample templates, or you can start from scratch, or you can use a saved template. The different sample templates are for a single room, like a bedroom, for 2 rooms, like a living and dining room, for 1-bedroom apartment, or for a small house. Today, we will use the 1-bedroom apartment sample template. So let's start. As you see, in a matter of minutes, the template has been generated. On the top, you will find the cards for the various rooms, the bedroom, the living room, the bathroom, and the kitchen. And below, you will find configuration options to change settings such as flooring, walls, the different room types, the connections, as well as the furniture. So I'm going to use the default and say, generate the world. Here you can see that you can probabilistically randomize the floor plans as well as the interior furniture variations. So I'm going to generate 2 different floor plans and keep the same furniture variation and hit generate. So now RoboMaker is generating your resources for you. So this might take some time to run. So let's jump ahead. So before this demo, I completed one of the generation jobs. So I'm going to click on that. And these are the 2 worlds that was created. So you can click on the world and visualize it in full screen. You can go back and look at the worlds that were generated. So what I'll do next is I want to export this so that I can use it in my development environment. So I'm going to specify a RoboMaker, an S3 bucket, where I will export these worlds to. So now I have created an export job, and once that is finished, I will have the world be generated in the S3 bucket. So next, let's go to the development environment. So RoboMaker comes with a cloud-based development environment in Cloud9 that is pre-installed with ROS. So you can start and create your own development environment here. Let's call it the webinar test. It comes pre-installed with ROS distribution. I will choose melodic, and you can give it an instance type. And you can choose your default VPC and subnets for testing. So I already have a development environment that I've created that I'm going to use for this demo. So let's open that. So this is the Cloud9 development environment for RoboMaker. For today's demo, I will use the AWS RoboMaker CloudWatch sample application. I have cloned this from the AWS Robotics GitHub repo, and you can see the folder structure here. So simulation applications in RoboMaker come with the robot workspace as well as the simulation workspace. Next, I followed the steps in this GitHub to build and bundle the robot application. I also copied my WorldForge world that I exported from the S3 bucket, and I have unzipped that in this source directory here. So next, what I'm going to do is I'm going to copy my output bundle files, which are in the bundle folder here for the simulation workspace and the robot workspace, and upload them to S3. So let's do that here. So that's the simulation output, and I'll do the same thing for the robot workspace output tar file. So that's it. So we were able to bundle my sample application with the WorldForge world, and next we will go to the console to launch the simulation job. So let's go back to the RoboMaker console and go here for simulation jobs. So here you can start a new simulation job. You can specify the number of hours or minutes, the simulation job duration. You can specify the failure behavior, whether you want the simulation to fail or continue. So I'm gonna choose fail. You can specify the ROS distribution. You remember we chose the melodic distribution earlier, so I'm gonna keep that. And you can specify an IAM role. So I'm gonna use my default IAM role so that I have access to some AWS resources. As I mentioned in the webinar, that AWS provides a scalable simulation interface, so you can actually scale your simulation units all the way up to 15 simulation units, which is 15 vCPUs and 30 gigabits of memory. So I'm going to set that up, but you can choose that to limit the cost and the number of simulation units that your simulations have access to. Next, I'm going to specify an S3 bucket for the output and log information from this simulation. So I'm going to leave the VPC information optional because I'm not going to do any networking for this demo. And let's click next. So here we need to specify a robot application. So this is the bundle that we had created in the previous example. So here I'm going to go to my S3 location. That I had uploaded the output.tar file. And the launch package name is CloudWatch Robot. You can check that by going back into your development environment and looking at what the launch packages are. So if I go to the robot application and I go to my source folder and I can look in the CloudWatch robot package, the launch file is awaitcommands.launch. Great. I also need to set an environment variable for the Turtlebot robot model. So we're going to use the waffle pie robot. Okay, looks good. Oh, I need to specify an application name. So I'm going to say let's click next. Now we need to do the same for the simulation application. I'm going to specify a name. I'm going to choose the Gazebo 9 software suite and navigate to my S3 bucket. Here, I'll specify the launch package name. Again, you can go back to your development environment and you can check what your launch package name is in the simulation workspace under CloudWatch simulation package in the launch file. So we're going to use the WorldForge Turtlebot navigation launch package. Again, I'm going to set the environment variable. And review all the different options, and then create a simulation job. So you'll see that this will take a little bit of time to set all the resources. In the interest of time, I'm going to jump ahead and to a running simulation here. So when the status turns running, you can connect to the Gazebo client as well as to RViz. All right, so now we have the status of our simulation job is running, so we can connect to the Gazebo client and RViz. So I'm going to fire these up. All right, so we have the Gazebo application running here, and you can see the Turtlebot robot. We also have the map of the robot in RViz, as well as the camera topic that we're able to visualize. Here, I can send a 2D nav goal to the robot and change the direction it's going. For example, if I want it to go in this direction, I can specify a nav goal, and you'll see that the robot will respond and change its direction and now go this way. So there are a number of things that you can use to test in simulation. For example, if I want the robot to go behind this couch or underneath this table, I can specify a nav goal and I have the robot go in that direction. And using the synthetic camera data here, you can see that you're getting the visualization from what the robot is seeing, and you can use that to train machine learning algorithms or train the deep learning algorithms to make inferences based on the simulation data. One thing I forgot to mention is that this world is the same world that we had generated using WorldForge, and you're able to now run this in Gazebo in RoboMaker. So let's go back to the console. So I'm gonna exit out of here. One thing you can do is AWS RoboMaker has a simulation job API, and that will allow you to run multiple of these Gazebo worlds in parallel and concurrently and run many simulation jobs that we'll cover in a future demonstration. So that's it for the demo. I'm going to go back to our webinar. Hope you've enjoyed the brief service demo of WorldForge and launching simulations in RoboMaker. I want to leave you with some resources to dive deeper into the features. To learn more about how your business could use AWS RoboMaker, check out our website at aws.amazon.com/robomaker. There, you will find links to our technical blogs that describe many use cases like automated testing and fleet simulation. Finally, get hands-on at robomakerworkshops.com. In addition to the simulation service, the RoboMaker team has created and published multiple useful assets to our open source GitHub repo. This includes cloud extensions that can be included in your apps to easily upload ROS bags to S3, connect to managed AWS machine learning services for text-to-speech, natural language comprehension, upload logs and metrics to CloudWatch, and stream video into the cloud using Kinesis Video. We have also provided multiple 3D worlds for Gazebo that you can use out of the box to accelerate your simulation development. Here's the link to our open source code assets. RoboMaker also provides a fleet management offering and helps robotics companies with scheduling robot deployments with ease. You can now be in control of the deployment schedules rather than be dependent on robot manufacturers to push deployments. The RoboMaker service leverages the AWS IoT Greengrass technology. The first step you can take is to register the robots into the RoboMaker service and organize them into fleets. The fleet could either contain robots of the same brand or robots of the same type. Next, the service enables you to upload new versions of the application into AWS S3, our storage service, and with just a few clicks, securely push deployments to an entire fleet of robots. This capability is especially important as enterprises scale their usage of robotic devices. Users can also check if the robot meets certain conditions before the deployment is pushed out. For example, ensure that the robot is not performing a mission at the time of deployment. Additionally, RoboMaker also has built cloud extensions to widely used AWS services such as Kinesis video streams for video streaming, CloudWatch logs for dashboarding, and S3 for storing ROSBAC data. I want to end by summarizing our learnings from today. AWS RoboMaker enables customers to launch simulations for robot applications with a simple API call. The services provide built-in support for ROS1 Kinetic with Gazebo 7 and ROS1 Melodic and ROS2 Dashing with Gazebo 9. With a single click, you can open GUI interfaces for the Gazebo client, as well as common ROS development tools, RViz, RQT, and access to a terminal to interact with running applications. In addition to physics-based Gazebo simulation, you can run simulations with previously recorded ROSBACs. Finally, we learned about WorldForge, a new feature that enables customers to dynamically generate 3D worlds. Today, the service supports generating randomized floor layouts and furniture configurations for home environments. Hope you enjoyed learning about AWS RoboMaker and especially its simulation features and use cases. Thank you for your time today and hope you enjoy simulating your robots in RoboMaker.